Hello, everyone. I am Taha M. Muhammad, USA Kurd. I am a citizen, of course, and I did solve Collatz sequence in easy way in two ways. The first way is 9 pages. 9 pages. This one, let me go to first way. Okay. This one is first way. First way solving Collatz sequence. And the abstract or the theory is telling when n is a natural number, okay, when it is even, divide by 2, odd, multiply by 3 plus 1. This should be if and only if equals only if sequence of n. It means when you use those two rules, becomes n over 2 or 3n plus 1. Why I told n over 2? When it is even, I divided this n, divided, but I don't know which one. Maybe it is odd, then multiply by 3 plus 1. This will continue forever, we don't know now, but the Collatz is telling maybe suppose this goes to 1. That means when it goes to 1, use the rule again. This is odd, multiply by 3 plus 1, becomes 4. 4 divide 2 becomes 2. 2 divide 1, that means you are looping around. 4, 2, 1, 1, 4, 4, 2, 1, 1, 4, 4, 2, 1. No any more elements. Okay? Then, and this one is equivalent to what? To this L, it means a loop. L, it means a loop. Sequence of n should be those elements in the sequence can loop around, which are 4, 2, 1. Okay. And how I prove that? Impossible. I take all natural numbers like 1, 2, 3, 4, 5, and add, multiply by 3, and even divide by 2. This is impossible. You cannot reach this situation. That's why I went to loop strategy. Loop. Only take care of loop, not those. Okay, how? I have to tell how many elements are here in the loop. 3. But before we start, people telling maybe at some point, some numbers has a loop only 1 element. Somebody tell, who knows, maybe 2 elements in a loop. Or 3, we saw some numbers, but we cannot prove all numbers as 3. Okay, then I am telling R equals number of elements of loops. This is 1. Second, see how many letters you see here? All are natural number because I am going to use those. Okay. Let us start the proof. Let the loop has only 1 element. 1 element comes from all integers and the natural number. I am taking all natural number, see which one will give me 1 element in the loop. What shall I do? Then I have to create a strategy here, a tactic. This one. This is circle. I need to start and come back again to same place. This is an element x. I took it from, this could be trillion, could be 1, could be 7, could be 9, we don't know. This represents entire natural numbers. If it is even, do you see E? Divide by 2, suppose goes to itself. From x to x, the loop. From x to x. Okay. Now, when this is even, I divide it. It is there. I name this a cloud. Do you see how I made cloud? Okay. Or maybe this x is not even, it is odd. I put O. And O, suppose, do what with it? Multiply it by 3 plus 1. This is second cloud. The result is, I told it, cloud. Okay. Now, go make equation. X over 2 equal x. And x value is what? And 3x plus 1 equal x. And x value is what? And I made a little table here in order we solved the equations. Cloud, we had 2. Okay. And the first cloud equal x implies that x is 0. And 0 is not positive natural numbers. That means the 0 not in the loop. That means nothing value for x. The second cloud may be equal x, and x value became negative half. Also not belong to loop. Then I will tell, therefore, loop of Sn not equal to a set with one element. With one element for entire natural numbers. This n is not x, no. This n here, n, could be 5, could be trillion, million, we don't know. No, any number in natural number going to give me a one element, a loop. This is clear? After that, I have to go to study a loop has 2 elements. Okay. This circle, this loop, I told has 2 elements. This is R value is 2, R, letter R. 2 elements in the loop. Is this correct? We don't know yet. This is number 1, always to start with x. And if it is even, divide, you came to y. This, it means x comes to y and y goes to x. This is the loop. But we'll see, this is really will happen. Even divided by 2, this is one cloud here. And maybe this x is odd. Then multiply by 3 plus 1. We have now this one, x over 2, even or odd. Let me tell you, this even if it is 16, we have 8. Then this is e divided by 2. If this is 14, is even, divide by 2 becomes 7. 7 is odd, multiply by 3 plus 1. You get it? Of course, one of them is correct, not 2. Okay, come to this one. We told this was odd. Now I have even here. 100% this is even. Even divide by 2. We have 3 clouds equal each one to x. And solve for x. You have 3 equations now. Cloud 1, 2, 3, each one equal x, and this gave you 0, this gave you negative 2, this gave you x value negative 1. Those are not belong to natural number. That means no value for xy. It means I prove it for all natural numbers, from 1 to trillion, after trillion, forever. There is no a loop with 2 elements. We are done from 1 element, 2 element. We come to 3 elements. Okay. Let loop of any natural number, any, maybe will give you 3 elements. We'll see. This is circle. put three elements, x, y, z. That means x to y, y to z, z to the x, like that. Loop. Let me see, this is correct. X is even, divide, add, multiply. This x over 2, two possibilities, like 7 or like 8, because 16 divided 2 is 8. When it is 8, even, divide by 2. Okay? And here, this is add, multiply by 3, plus 1. You arrive at here, this was add, this is even number, 3x plus 1. Divide by 2. Those are three value of z. Value of z. But this is not the end of loop. Suppose I go to x. Study each one of those. When we divide it, 14 to 2 becomes 7. We go with add. If divide 8 to the 2, this became 4. Divide by 2. You see that? O and E. And this one, 100% is even, this one. Because it was add, you multiply by 3 plus 1, you got that. And now divide by 2, became 3x plus 1 over 2. Anyway, this is the same way, even, it is here. When you divide even, you have two possibilities. Odd, even, we got how many clouds? 1, 2, 3, 4, 5. Each one equal x. And you will see, of course, this chart, this design, sketch, it is mine, unique in the world. Taha has a sketch. It is mine. Okay. Thank you so much. Now we can solve those. Solution. 5 clouds. 0, no. 4, yes, good. 2, yes, good. 1, yes. Negative, no. That means if you take value of x enough, when x is 1, then the loop will go to a 4, multiplied by 3 plus 1, 4. 4 divided 2 is 2. 2 divided by 2, 1. This is the loop. That means I did proof all natural numbers goes to when they have 3 elements in the loop is 1, 2, 4, the loop. But somebody telling me, what about 4, 5, 6? Please, no need for that, but that's okay. It is fun. Let me do that. X, Y, Z, T. I did this, same rule, but I got nothing. I got nothing, see? Sorry. Okay. Clouds, 8 clouds. No one gave me a natural number. That means no values for x, y, z. Then no loop. 4 elements in a loop, no. Same way, 5, no. 6, no. Maybe you will tell, show me. Okay, but I have to change this design. I have to change this design. We go to something else. What's that something else? This one is unique in the world again. Something new, very unique. This is not math. It is design. I tried 5 years, 6 years working with it. And twice I died with heart attack at emergency room in Northfield. 2019. It was January 13, 2019, 11 o'clock. Twice I died. But anyway, long story. I have that in my book. Yeah, Taha's Life in America at Amazon.com. Okay. R, I told you, is number of elements of a loop. And let x is in the loop. Always take x in the loop. Okay. When we have one element, I have that element possible as even or odd. Then this black spot suppose give me 2 results. See, 2 blacks here. Why? Even odd situation. Okay. We go to second one. Here, of course, any cloud will not give you X value. I showed that. And 2 also I showed that there's no values for those. When I come to 3, by that sketch, Taha's sketch, and Taha's sketch, you saw when R is 3, like X, Y, Z, you saw results. See, I highlighted. And this will give me 1. If this is equal to X, I will get 1 X. X is 1 enough. Then use the rule of Collatz, you will get 1, 4, 2. Okay. What about 4? Maybe you are telling me what are those red, and I will tell you. When you are at this result, when you are here, ignore that anymore. Don't look at this. Look at down. You make a symbol for yourself. Tell this is red. Because even odd, then you have 2 answers. This one just even. This brown. You have 1 answer. Green, how many answers? Even or odd? 2. 1, 2. Dark blue, even odd. 2 blue. You suppose see 1. Where's the other? In another page, you will see it. See. Another page. You saw that? Okay. Go back a little bit. What about this light blue is what? Let me show you light blue. It was what? This light blue was even. When it is even, you have only 1 answer. Divide by 2. Where is that light blue? Light blue, it is here. That means we have no highlighted fractions here. No highlighted. It means any one of those equal to X will not give you any result. What about 5? This is 5. This one 5. Okay. In 5, we got how many elements? A lot of elements we got. The cloud, I mean. And each one try to equalize to X value top, remember, in order to complete the loop. And this equal to X, no answer, no answer. Nobody gave me answer, natural number. That means no loop has 5 elements. What about 6? Yes, 6 has elements. How? Because if you equal this to X, you will get 16X minus 9X, 7X equals 7. X is 1. It's done. Why 6 has 3 elements? It was 6 elements a loop. I will tell you why. Because the circle, I got to circle this. Simple circle. This one, for example. This is number element is 3. If it is 6, put point here. That's okay. Points. And X go to second, second to third, third to 4, 4, 5, 5 to 6, then to itself. Total 6 elements. But this repeating what? Telling 1, 4, 2, 1, 4, 2, 1, like that. That means your set of loop is 6 elements, yes, but they are repeated. 1 to 4 and 1 to 4. It means 6. This will tell me something. Remember, I got a connection here. See? Look. We go to our design, this one of 6 elements. I saw highlighted in 6. This is 6. Highlighted. Okay. What about 7? I didn't do 7. Then I have to think about pattern, okay? I have to think about pattern. What is going on with those fractions related to x? See? When this is equal to x, I take always the smallest one. I do not got the big one, 28, 14. Looks like this will give you 2, give you 4, give you 1. See? Anyway, we come to pattern. When R, the loop, has one element, only x, then x equals what? I figure out this pattern. Always denominator 2, because we divide by 2. Always denominator 2. What does mean this 2 here? It means the value of R. The value of R. Okay. What does mean 0? The 0 is 3 times what? Becomes 0 plus 2, the answer is 2. Do you see that? The 0 is k. 3k plus 2 becomes 2. And from here, always denominator in all of them is 2. To the exponent is the value of R, the value of R, and minus k, 3 times what? 0. Then I got third, no answer for here. Okay. With 3 times 1 is 3. No need to tell plus 0, no need. R is 3 and k is 1. R is 3 and k is 1. Come here. 3 always, let's start with 3. 3 and this 1k becomes exponent for 3. Multiply to x. Then write without x, repeat 3, but reduce the exponent just 1. 3 to the 1, 3 to the 0, and stop. Then when you write 3 to the 0, suppose appear 2, but that 2 always come from doubling of this. When this is 0, 0 times 2 becomes 0. Later we'll learn more, okay? Come to 4. And when we have 3, we have elements, yes. X value is 1. Y will be 4. Z will be 2. And the loop is this. What about 4 elements? See, those value will not give me X natural. That's why. Again, what is 4 is R. What is 1 is K. And you ignore those, because this include with the R. 3 plus 1 is R. 4. Anyway, this 4 is R and this 1 is K. Later we will show you RK. Now I am finding pattern. No result, empty. When 5 is empty, 6 empty, no. 1, 4, 2. 7 empty, yes. No answer. After 7, I went to what? After 7, 9. Attention, I came to multiplication of 3, because I saw 3 has loop, 6 has loop. That means 9 has loop, 12, 15. I am thinking about multiplication of 3. Any loop elements, the total numbers of elements divisible by 3, then you have a loop. And that loop is what? Only 1, 2, 4. Okay. let me study this. R is 9, exponent for 2, minus k value, this 3, multiplication of 3. And here what you do, this 3 to this exponent 3, multiply to x, plus reduce 3 now, exponent. 3 to the 3 becomes 3 to the 2. But appear with it what? Multiplication to the 0 first appear. Then 3 reduce it, the exponent, and 2 increase. How increase? 0 plus 2. See? 2 plus 2, 4, like that. But finally, you see relation when you're done. When it becomes 3 to the 0, stop. 3 to the 0 always stop. When you come to the 4, always is double of the first 3 to the 2. See? 3 to the 2. That 2 multiplied by 2 finally is this. Anyway, you got answer with 9? Yes. 1, 4, 2. Good. 12. See? 12. And this is 4. Has answered yes, because x is 1. 15 has answered yes. Then from here, I am going to put pattern. I tell it part A. If R is equal multiplication of 3, like 3 times 1, 3 times 2, 3 times 4, 3 times million, like that. And this multiplication of 3, the coefficient of 3 is k, let x equal this fraction. And fraction is what? Very easy. Always start with 2 here, to the r, minus k. This is r and this is k. You are done from denominator. And this one, the first term has x only. This is 3 to the k. See the k from here. And then go play. Minus 1, minus 2, minus 3, minus, like that. But we have a gap. We cannot go forever. We don't know our k value is what. But the 2, what happened to the 2? 2 will appear when you see first 3 without x. See, after x, you see 3, no x. Instead of x, you put 2 to the 0 first, always. Then add 2 for 2. Add 2 becomes 4, like that. But finally, when we came here, 3 to the 0, stop. 2 to the, look at the exponent of this second term for 3 coefficient. Exponent k minus 1 multiplied by 2. 2 times x minus 1. And this equation 1 always equal 1. Okay? Because I started from 1 to the trillion maybe, always gave me this kind of fraction. Some of them worked, had x value, some of them didn't have. I realized that those values only comes out when r value is divisible by 3. Okay. That's why this one, it is true, and this is 1. Why I repeat this always? It is a long process. I name it, this one, G. Letter G. Okay. Implies, I know x value, see, x value, this one, let x equals this. Final is what? 1. Okay. When this is correct for r, is it correct for r plus 1? I'm going to induction situation proof. I told if r also equal 1, what about r plus 1? Later I will come to that, okay? But first, I need to show you what does mean G. Because this is maybe difficult for you always to write this. You tell this G. G. And this G, because x is 1, x is 1. When you do cross multiplication, you will get that x times denominator 2r minus k and minus 3 to the k equal to the g. I told this is g. Okay. Then when x is 1, then g value always is this. For any number, numerator always constant. For any loop, constant. You use this. G is 2 to the 2k minus 3 to the k. The exponent of 2 double of exponent of 3. This value of g. Value of this denominator. Okay, if you tell me the number of loops is 47, can I find answer? Yes. Okay. Then we come to the 2. Part A, we told if this true is 1, is when r equal 3, but instead of k, I exceeded one more. See? K plus 1 becomes, of course, 3k plus 3 when you multiply. Is this true also? Question mark. Equation 3. Is this true? Okay. Proof. I did write the question itself asking me, is this equal 1? I don't know yet. I am working. See, x equal to that. This is given to you. Apply. Do cross multiplication. This times x and bring that x first side. X is common. You got that. Put r value, which is 3k plus 1. And 3k minus k is 2k. 3 minus 1 is 2. Okay, go. You have x here, of course. Equation. This is equation 2. And stop here. Can you make this equation 2 looks like equation 3? Do I have equation 1 there? Equation 1. This is 3. Okay. Okay. Accidentally I put 3. Suppose I put 2. But that's okay. Okay. I need to make sure this equation 2, this one, is same as above. How? I started from here. Let k plus 1 equal m. Why I am doing this? You see? K plus 1. I made it what? One letter. Why I am thinking like that? What's the reason? Because when I go top, my pattern, this is my pattern. Do you see here? 3 to the k. When I have here 2 term, I have to make that 2 term one letter. Equation 2. I am in equation 2. I told k plus 1 equal m. Then multiply by 2, this equation becomes 2k plus 2 equal 2m. Then 2k value how much? 2m minus 2, solving this equation. And then what will happen? And this one, 2 common, becomes m minus 1. And k equal what? M minus 1. See, I try to find value of k, value of 2k, value of k plus 1 in order to substitute, and I got that. 2mm like 2kk, remember? In previous equation, 2mm, and that one was 2k and k, 2mm. And this one, m minus 1, when this is m, this will be m minus 1 without x. And that too, you know, I did substitute here maybe. See? Yeah. K value is m minus 1. And k minus 1 value, and you go like that. When you come here, 2k is what 2k? A value. S 2 parenthesis m minus 1. Do you see this? Okay. Now, I thought, okay, this looks like G. Why? Because same pattern. If you compare this pattern with equation 3 top, you will see they have same exponent, same level. I have right to tell this is G. This pattern is same as equation 1. Implies that Gx equal G. By substitution and solve that for x, G divide G is 1. Then x is 1. That means loop will be what? When we have 1, multiply by 3 plus 1, 4. 4 divided 2 is 2. And repeat that, you will see it is a loop, 4 to 1. That's why I am telling loop of Sn for all n belong to 3, 6, 9, 12. Why I am telling this? Multiplication of 3. What about those? They are not multiplication of 3. Suppose I have 7. What's the pattern of that? Of course, I know before we studied 7, 15, but let me in general. Let R equal 3k plus h. H is less than 3. And I told you before, if you look, that h is a natural number, not 0 in it. Then the value of h exactly less than 3, it means 1 or 2. 1 or 2. Okay. Like 3 plus 1 becomes 4. No loop. 3 plus 2 is 5. No loop. Okay. And then your equation is this always. 2 to the r minus k. And k goes to exponent for 3. Multiply by x. And then without x, k minus 1, k minus 2, k minus 3. And 2 will appear with 0 exponent. And plus 2, plus 2, plus 2, plus 2, like that. Finally, when you arrive 3 to the 0, that means the 2 will take double exponent of that 3 after x. See, k minus 1 times 2 is here. Okay. Look. And this value top, I told it what? It is g. Or do this first. Denominator, multiply this x and bring that x to this side and x common. You got this value from here, 3 to the nth, which is g. This one is g. That means this value without x, when x is 1, going to be this. But this one is greater than this one. See, 2k plus h, and this one has no h. This one greater than this. That means greater than g. When denominator is g, numerator is g, denominator bigger. That means this is fraction, like 1 over 2, 7 over 10, like that. When we solve this equation for x and g divide to this coefficient of x, and this is fraction, less than 1, then this value of x is not natural number, then no loop. See, I prove it that those number of loops where they are not divisible by 3, not multiplication of 3, no answer, no loop. That's why I told the loop is empty, nothing. Okay, nothing. For what kind R? 1, 2, 4, 5. See, I didn't tell 3 here. I didn't tell 6. After 8, I am not going to tell 9. No. This kind, 3K plus H. Those has no loop. The loop is empty. The union by parts A and B will be just this union, which is 1 to 4. Conclusion now, when you solve any problem, you tell somebody, tell you, as the loop has, Collatz loop has 92 elements possible, immediately tell no. Why? Because it is not divisible by 3, 92. 90 has it? Yes. Okay. Anyway, I did prove for you this conclusion. This expression is G, x equal that over 2 to the r minus k, and this is equal 1 in equation 1. Okay. That means x equals 3 to the k, x plus from here to there is G, equation 1. Let us say this. Then substituted that G value, x equals 3 to the k x plus, do you know G value I found it here? And bring it here. That's it. This equation 4 is to tell you x belong to loop or not. Somebody telling you 1,271 has a loop, you tell no. F is not divisible by 3. Or you use that. Any loop number, you figure out about R, like 17, for example. 17, and K is what? 17 comes from 3 times 5, 15. And 2 is 17. K is 2. 17 and 2. 2. 2 times like that. Okay? Did I tell correct? I thought 17. I have to write down one more. I told I forgot the loop number. If you have 17, 17 is 3 times 5. 5 is K. K is 5. R is 17. 5, 5, 5. Then put to Google, immediately will give you the answer for X. No Google or any calculator, or you do it by hand, will give you the value of X. If value of X is decimal, you tell no. Negative, no. 0, no. But it is 1, accept it, say okay, when it is 1, that means we will get loop is 1, 2, 4. Final conclusion is this. If R is divisible by 3, you have a loop. If R is not divisible by 3, you have no loop. By part 1 and 2, then union, you will get that. And finally, I know it is difficult by this situation. You suppose live meeting with each other to stand up and tell me what is this, what is that. But by video, I don't know how much will. See this one, this paper, this graph for y equal half x. That means even number divided by 2. And this line, this one, is when r multiplied by 3 plus 1. You start from here, for example, any number. You go up, if it is even, touch this and come like that, and you do that automatically. See from 10, see how many movements I made. Then I came back, I saw myself, I am looping here. Who are they? 4, 2, 1. See? 1, 1, 4, 2. 1, 4, 2. That means I have this rectangle, triangle, 3 points. And thank you so much. I hope you got something from me. And it is at Cambridge open a Gates University. You can look at it. My solution is there. This is first way. And I have second way, only one page. Amazing. Only one page, please. Believe me. But unfortunately, some math editors, cannot digest that. I give them the right, but at the same time, they are wrong because they are not contacting me. So what? They invite me to one university, and we talk for 1 hour. This is the solution for the world. World is looking for this solution. And why this hiding? Please, don't hide this. And see how much activity I did, 9 pages. 9 pages I did, all are correct, 100%. But if you have any question, unfortunately, how you ask me? Yeah, see? But anyway, let me stop video here. I will start second video. The second way is only 1 page. And thank you so much. I am going to make the camera off.